Hello everyone, welcome to our video series on data science using Python. So in this video, we are going to do a case study on classification. Now, a case study on classification typically involves exploring and solving a real world problem using classification algorithms. Now, this classification is a type of supervised learning where the goal is to predict the categorical class labels of a new instance based on the past observation. Means we have a data set with us. Okay, on that data set there are variables. Okay, based on that variables we are going to predict a new instance. Okay, so let's just first see the problem, that what is the problem and how we are going to solve that. Okay, and what we have to do, what is our main objective, and then we are going to discuss further. So the problem statement is that subsidy income delivers subsidies to individual based on their income. Okay, so subsidy income is a company which delivers subsidies to individuals based on their income. Okay, now accurate income data is one of the hardest piece of data to obtain across the world. Now this subsidy income has obtained a large set of authenticated data on individual income based on their demographic parameters and a few financial parameters. Okay, now this subsidy income wishes us to what to do, that they want that we should develop an income classifier system for individuals for the subsidies, to find out that to which person we are going to give the subsidies and to which person we are not going to give the subsidies. Okay, that is the main thing which we have to do here. Now the objective is that we have to simplify the data system by reducing the number of variables to be studied. Okay, so see, there are 13 variables. So it's not necessary that all 13 of the variables are useful, will be useful in finding that we have to which person we have to give the subsidy or to which persons we have to not give the subsidy. So is it not, it's not necessary that we are going to use that 13 variables. There could be some variables which are just there only for the data. Okay, so that is the thing. Then, without sacrificing too much of accuracy, and we don't want to sacrifice means we don't want to lose too much accuracy also. So for that, what we have to do, we have to just create such a system that would help the subsidy income in planning subsidy outlay, monitoring, and preventing the misuses. Okay. Now, so for that, what we are going to do, we will see the relationships. We are going to visualize the data based on two different variables, and then we can uh, move on, and then we can see some algorithms in which we can just easily predict. Okay, so now before moving forward, uh, let's look out some of the variables. Okay, that what are the types of variables? So this is a table describing some of the tables of our data set, and then after that we directly go and look into our data set only. So this is how our data set is. You can see uh, there is few variables: age, job type, education type, and marital status. Okay, and the data type of age, you can see it is in integer format. It describes that it is the age of the individual in years. Okay, then in the job time, it is in string format. You can also say it in object format, and it describes the working status of person, which sector does he work in, and some of the categories inside this job type variable is federal government, local government, private, and there are 5 more categories. Then there is ed type, that is education type, which is in string format. Okay, which describes us the level of education that particular person has. Okay, and the categories inside this variable are 10th, master, doctorate, and 13 more. Okay, means 13 more categories are there in this ed type variable. Then there is marital status, which is also in string. It describes the marital status of the individual, means if he is married, divorced, or whatever. So categories on this variable is divorced, never married, married, AF spouse, and Then there is four more. So we'll see each of them. Now let's just do what? Let's just start with the coding and let's look out all the columns, means all the variables, okay, just by loading our data set. So for that, first of all, let's start with our libraries. So as we have seen that which library we are going to use. So we have imported pandas, then we'll import numpy, and then we will import seaborn, and let's just import matplotlib.pyplot also, so that we can use some of the methods of this matplotlib also. So these are some few libraries which will import. Okay, so these libraries has been successfully imported. Now let's just do what? Load our data set. So let me create an object for that. Let me use the method read CSV. Okay, so this is a new CSV file, okay, that is income.csv. Now, first of all, let's just do what? Let's just print the data income save. Okay, so in this file income.csv, when we have converted into a data frame, so now you can see when we have checked the save of it, so it has 31,978 entries and 13 variables. Okay, now let's just see each of the variables. Okay, now here you can see age, job type, ED type, that is education type, marital status, then there is occupation, relationship, race, means based on colors, gender, capital gain, capital loss, hours per week, working of the person, means per week how many hours that particular person works, then native country is there, and then the last variable is salary status, that is sal stat. Okay, so these are the 13 variables. Okay, and based on these 13 variables, what we have to do, uh, we have to create uh, such a system that will help the subsidy income in planning the subsidy outlay, monitoring it, and preventing the misuses. Okay, now so let's just first of all create a copy of that, because as we have already seen this thing, that first of all we'll create a copy of that and then we are going to work on that copy only. Then what we are going to do, we will do the exploratory data analysis, and in the exploratory data analysis, first we'll know about the data, that how the data is the data has some missing values, and if it has, then how we can handle it. Okay, so first of all we are going to know with the data, okay, know the data deeply. Then we will do the data pre-processing, it means handling the missing values and all, and then we'll see the relationships and data visualization. So for that we can use the cross tables and data visualization, okay, methods. So now let's get started. So let's first start with printing the data info. So as you can see, when we have printed the data info, so all the column names, you can see the data columns, total 13 columns. You can see that there is 31,978 entries. Indexing is starting from 0, so 31,977. Okay, because it's starting from 0, that's why. Then you can see the non-null values. So approx all the variables for now, they have no missing values. Okay, and you can see the data type of each variable also. Age is int64, then job type, ED type, marital status, occupation, relationship, race, gender is in object format, and then the capital gain, capital loss, hours per week are in integer, and then the native country and salary status is also in object format. Okay, so you can see the memory uses also. Now let's check for some missing values. So as we already know, for the missing values we can use the isNull method. So when we apply the isNull method, so as you can see, it is returning for each value, it is returning in boolean. So we have already discussed in our previous videos. So if you don't, if you don't watch that video, so please go and watch that video. Okay. So, okay, I'll explain it one more time that when we use this is null method, so it returns in Boolean. So if it is false, it means that it is not a null value. And if it returns in true, it means it is a null value. Okay. So now finding like this, that if one value is missing or not, it will be very hard. So for that, what we can do, we can just directly apply the sum method. So it will give you all the missing values for all the columns together. Okay. So let's just apply that method. So now you can see when we have applied the sum method on is null, so there is 0, 0, 0 for all the variables because all the variables have no missing values. So it means there are no missing values for now. So now let's just do what? Let's just summarize the numerical variables. Okay. So for summarizing the numerical variable, let's just create a summary num object. In that, let's apply the describe method and let's just print the summary. So now this describe method is used to summarize all the numerical variables. So as we already know that age, capital gain, capital loss, and hours per week, these are the four integer variables. So on that only this describe method is working. So you can see the total count, then the mean value of all these three, the standard deviation, the minimum, the first quartile, the median, the third quartile, and the maximum value also. Okay. Now let's just summarize the categorical variable also. So for that, what we can do, let's create a different object, summary data. Okay, not data. Let's just do it like summary category. So summary cat. Then on our data, we'll apply the describe method. Okay, and then we'll use the parameter include, and we are going to include the objects only. So we'll write O. Okay, and then let's just print the summary cat. So now for all the object means for all the object variables, now we are getting the count, unique, top, and the frequencies. So now let's start with the first job type. So in the job type, as you can see, the total count is 31,978. Unique values are 9. Okay. The top is the private, and the frequency of the top is 22,286. Then, then for the education type, the total values are same. Unique values are 16, and the top value is HS grad, means higher secondary grad, and then the frequency of that is 10,368. Then for marital status is also the count is same. Total 7 unique values have been used. The most used one is married CIV spouse, and it has a frequency count of 14,692. Okay. Then for occupation, same count, unique values are 15 that has been used. The top one is the professor specialty, which has a total count of 4,038. Then there is for relationship, 6 unique values, husband, 14,947. For race, 5 unique values, white is the top, which has 27,430 out of 31,978. And on the gender, there is 2 unique values used on gender. Okay. And the top one is male with 21,370. For native country, there is 31,978 count. 41 unique values are there for the native country. And the most top one is United States with 29,170. Then the salary status. Salary status is also in object format. So that's why it has, when we have included the object, so it is also coming along with the object. Now you can see 2 unique values are there. The top one is less than or equal to 50,000. Okay. Means earning, and it has a total frequency of 24,283. Now let's just uh, let's just do what uh, we will take the job type and the occupation, okay, and based on this job type and occupation we are going to look the frequency of each category. That means in job type and in occupation what is the total frequency of each category. So for that we will use the print function. Inside the print data, then we'll take our job type variable. In this variable, as we have discussed that if you have a categorical variable and we want to know the count of each categories, so we can use the value counts method. So we will apply the value counts method here. Now, when we have checked the categories, means the value count of each category in job types. So as you can see for private 22,286, with self-employed not income is 2,499, local government 2,067, and you can see a question mark here. Okay, so this is a special character which has 1,809 values. Then for the state government there is 1,279. Self-employed income, that was for not income, means they are self-employed but they are not generating income, so that value is 2,499. Self-employed and income means they are self-employed and they are earning income also. These type of people are 1,074. The people who are working in federal government are 943. Without pay which they are working is 14, and never worked is 7. So there are 1,809 values which are which are in question mark, means which are uh, blank, you can say, because if there is a question mark or a special character, so the data frame is unable to read that as an uh, empty value, nan value. So we have to especially we will explicitly convert it into a nan value, okay, and then we'll perform our operations. So now let's just do the same thing with our occupation also. So we'll just convert from job type to occupation. Now in occupation also you can see we are finding this question mark, means this special character, okay. So we are now sure that there is missing values also, but because there is a special character in place of the missing values, so that they are not getting considered as the nan values, okay. So for that what we have to do, for that first of all we can check the unique classes, means unique categories one by one, that how the names are there. So for that we can use the method present in the NumPy library, that is unique data job type, and let's do the same thing for the occupation also. So we can see we have the unique values, this question mark, okay, with a space. So now what we are going to do, and in both of them we can see the same question mark. So now we will read our data again, but this time with the property, means this time with a external parameter, you can say, that is NA values, which we already know the use of it, and it will convert all these values with a special character. So the value was a space and then a question mark. This was the special character. Because of that, our particular column was in, well, was not means there were missing values, but because of this special character, that missing values were not counted. So now we'll just read our data, means read our income.csv file, with these NA values. So now this special character means all the values with this special character will get automatically converted into a NaN value. So now let's just do what again? Let's just do the is null dot. So now you will see in the job type we have 1809 values, and in the occupation 1816 values. Okay, so now we will create an object missing. In this missing object, what we are going to do, we'll apply the isNull method and then the any method. And in this any method, we'll mention the axis equals 1. This means that we are considering at least one column value is missing. Okay, so that type of data will get stored in this missing one. Okay, so you can print missing dot head also to look out the sample data. So as you can see, one column will be at least missing. So those data will be stored in this missing values. Only those data, not all the data. Means only those data in which at least one column, means at least one column value is missing. So that type of entries will be in this missing data. Now what we will do, now to look at the all the missing data together, you can just simply use the toCSV method to convert it into a CSV file and give it a name. Okay, give it a name .csv, and if you want the index, so you can do index equals true. So in your means in your directory where you have opened this file, you will get that CSV file, so you can see that CSV file. Now there are some points that we have to note here. One point is that the missing values in job type is 1809. Okay, 1809, and missing values in occupation is 1816. Okay, it means that there are 1809 rows where two specific columns, that is occupation and job type, have missing values that are common. Okay, so if you look at this data, when you'll execute it and you'll look at the data, then you will notice that all the data means all the values means 1809 values where the occupation is NaN, so their job type is also NaN. But 7 values are like that, which is like this. If you notice the data here, 7 values are like that in job type, which are never worked. So that never worked will also be, because they have never worked, so the occupation will be also empty for those values. So we have to consider those values for the never worked also as NaN only. So now what we will do, we are going to simply take a data2, and in this data2 we will apply the drop NA method with axis 0, means all the entries, and then let's print the shape of it, data2.shape. So now you will see, because earlier it was 31,978 entries, now we have only 30,162 entries. Okay, we have dropped all the entries which has nan values in that. Now let's just do what? Let's find the relationship between them. Okay, let's find the relationship between the independent variables. So for that, what we can do, let's create a correlation object, and on the data 2 we'll apply the core method which is used to find the correlation. Okay, so now you can see the correlation between the age and the capital gain, then the capital loss, and then the hours per week. So it is very less. It is approx 1 means 0.1. So they are very less. And if you look at the capital gain and the capital loss also, so that is also very less. So there is no relationship between these data so that we can know. So let's just do what? Now let's just we'll do what? First, we are going to use the cross tables. Okay. And then we are going to visualize the data. So before going to do that, first of all, we'll extract all the column names. So for that, we can use the columns attribute. So this is all our column names. Okay. Now for the gender proportion table, now we have to find the gender proportion. So for that, we can create a table using the cross tab method. So let's create that and let's see how we can do that. So that method is in the pandas cross tab. Okay. In this cross tab, there are few parameters which we have to define. So first of all, on the index, we are going to define the gender. Then we will define on the columns, we are going to define the count, that we want the count. And then we'll make normalize equals true. And then we will print. So now you can see we have got the cross tab, okay, for gender, female and male, okay, based on the count. So we are getting the counts, and on the counts you can see that females are 0.32 and the males are approx 0.67. Okay, so these are the total counts of the males and the females. Now let's just look at the gender and the salary status. So for that, let me create a gender cell stat object. In this object, again, we can use the cross tab method. In this method, first we'll take the index. So index will be same data 2, and we are going to take the gender only. Okay. Now in the columns, what we will do, instead of counts, we'll take the salary status. So data 2, and then the cell stat. Okay, let me define the margins equals true for finding the total, and let me do the normalize also so that it will be converted into, and in this normalize, now I'll make it as index. Okay, now let's just execute the code. So code has been successfully executed. Now we have to print it also. So we'll print the gender cell stat. So now you can see gender wise for the female, based on the salary status categories, we have distributed it. So now on the female, you can see greater than 50,000 earning is 0.11, and less than equal to 50,000 is 0.88. On the male, you can see it is bit higher. Greater than 50,000 is 0.31, And in the less than equal to, you can see it is bit less in comparison to the female. It is 68. Okay. So now, because we have find the data for the salary status based on the gender. So now what we are going to do, now we will visualize the data, means we are going to create a count plot for the salary status. Okay. So that we can know that in combined for the both male and female, how much, means what is the percentage. So for that we can use the count plot. So before going to that, we have to do one thing. We have to convert, means we have to remove the spaces before this greater than and less than or equal to these two categories, which is in present in our cell stat. Because if we'll not do that, so it will throw an error to us. So first of all, okay, first of all, let's do what? Let's just see the error and then we'll do the solution of it. Okay, so we didn't face the error, so we are not going to see the solution. So actually the solution was that when we are going to face the error, because you can see the names were too big, as you can see greater than 50,000 and less than or equal to 50,000. So maybe it could throw an error because there were spaces before and after. So then therefore we can apply the strip method, okay, of that string class. So no issues. We'll see at the plot. So now in the plot you can see that there are, means the plot of the less than or equal to 50,000 is much greater, okay, than the plot of greater than 50,000. It means there are people, means there are approx 75% of people's salary status is less than or equal to 50,000, 50,000, and there are 25% of people's salary status which is greater than 50,000. Okay, so this was for the count plot of the salary status. Now let's just look out the variation in the age, that how many persons are between which type of age. So for that, what we can do, we can create a histogram for the age. So let's create a histogram for age. So for that, what we can do, sns.histplot data to age. Let's define the total beings for, so let's suppose, let's take 10 and let's make it kernel density estimate as false because we don't need this now. Okay. So now this is the histogram for the variation of ages. So now you can see the most peoples are between the age of 40 to 45. Okay. And as the S is getting increased, as the age is getting increased, so the number of person is also getting less. Okay. So this was for checking the variation of age. Now, what we are going to do, we will check uh, age versus the salary status. So for that, what we can do, we can create a box plot for that. Okay. So based on the age, we are going to create the box plot. Okay. For the salary status. So let's just do what? Let's just create it. So for that, there's a simple way. SNS dot box plot. Okay. Then we have to specify the X. So X will be our cell stat. Okay. and the Y will be our age. So let's give data to age. So these are the two box plots, okay, based on the ages, the salary status. As you can see that the less than or equal to 50,000 is, for that the quartile 1 is approx 20, means it's above 25, so it is approx 26, okay, and the third quartile is 45, and the median value is approx 35, and then for the median value is greater for the greater than and for the greater than 50,000 is approx, you can say it as 45. And if you'll see the maximum and the minimum values, so that are approx same for both less than or equal to 50,000 and for greater than 50,000 also. But the median value is more for on the age. The median value on the age means the people who have the age between 25 to 35. So you can say that type of people are in less than or equal to 50,000, and the people who have the more median value means the more median values on the age means, so suppose 45 approx 35 to 45, so they have a lot, means they have uh, greater than, means their earning is greater than 50,000. Okay, now you can print the median also. So for printing the median, what you can do, uh, on the data 2 you can apply the group by method, and on this group by method, first you will take the salary stat, and then you can take the age, and then you have to just apply the median method. So now you can see the median value for the greater than 50,000 is 43, okay, that is approx 45, and less than or equal to 50,000, the median value for this category is 34, okay, so approx it is also 35 only. So from that you can say the people with 35 to 50 years of age are more likely to earn greater than 50,000, and the people with 25 to 35 years of age are more likely to earn less than or equal to 50,000, okay. Now let's just do what? Now let's just visualize our data, okay. So we will perform exploratory data analysis. Uh, so let's start with the job type versus the salary status. So for that, first of all, let me define the figure. So I'll define the figure and I'll give a size of 12, 6, then SNS dot count plot. We'll first define the data. So our data is data 2. On that, the x-axis we will define as job type, and on the hue. Now, the hue is the parameter which is used to take a different variable also. So we will use this hue, okay. So let's execute our cell. So now you can look at this plot, okay. Now you can look at this plot. So in this plot, you can see that it is based on the job type. So on the x-axis, you will see all the categories of our job type, okay, and based on this salary status. So now if you look at the values, so the private sector, you can see the less than or equal to 50,000 with is the blue bar, and the greater than 50,000 is the orange bar. So on the private sector, you can say that it is very less. It is approx 70,500 only, okay. And the greater than 50,000 are approx the count for that is approx 5,000. Okay, and then rest of all the categories have less, means the private sector is only have the much bigger amount in comparison to the other categories. Okay, and no category have uh, only except the self-employed income, no categories have earned more than means greater than 50,000. The bar you can see, the orange bar is always, the height of the orange bar is always less than the blue bar. Okay, only in the self-employed income you can see a little, means the orange bar is little more. So if you want the exact value in numbers, in figures, if you want the values, then what you can do, then you can use the cross tab. So for using the cross tab, you can just do what? You can use the cross tab method for getting the exact value. Then in the index, you can define data 2, and you have to check for job type. So you can write here job type. Okay. Then you can take columns. So on the columns, you can define the salary status. So data 2 and sal stat. Okay. Then you can make normalize. Okay. So normalize in index format. Then apply the drop NA also, that if there is any none values, so it will just drop that entry only. So for accurate calculations. Okay. And then let's make for the totals, let's make margins equals true. And because we have applied normalize equals index, so the values will be in points. So we will just multiply with 100. So get the exact values in two figures, in two numbers figures. So for that, okay. So now you can see in numbers, based on the salary status categories, only the self-employed income has 56. Okay, has 56%. Okay, okay, and other than that, all the, means all the other categories have less than or equal to 50,000. Okay, is much greater than, in comparison to the greater than 50,000. So you can say only the self-employed income is the category in which uh, it is clearly visible that they have, means they have more greater income in comparison to other categories. So hence we can say that it is an important variable in avoiding the misuse of subsidies. Okay, so we can say that yes, it is an important variable, so that we can make sure that the persons which has more than, greater than 50,000 income, so they don't need the subsidy. Okay, so if they are also getting the subsidy, it means it is a misuse. So for that type of uh, for prevention from that type of misuses, this variable is very important. Okay, now let's just look out the education versus the salary status. Okay, so for the education and the salary status, I'll just do what? I'll just change this, okay, to ED type, and everything will be same. So let's just execute our cell. So now for as you can see in the when we have bring out the count plot of education versus the salary status, then you can see on the x-axis the names are collapsing. So for that, there is a method which we can use. That method is from the matplotlib library. So we will use plt dot xtakes, and in this xtakes we are going to use the rotation and we'll give it as 45. So now you can look at this names on the x-axis that will be in 45 degree, so they will not collapse. Okay, so there are few very few categories which has more, means which are more earning, means greater than 50,000 earning. Okay, so masters, you can see in masters the earning is, the persons are more in greater than 50,000. Then in professor of the schools are earning more than, I mean greater than 50,000, and in doctorate you can see that they are also earning greater than 50,000, but they are in less amounts. And most frequent amounts of persons which has all, means which has at least the education which is the higher secondary graduation. Okay, so that you can see which has crossed for the less than or equal to 50,000 is approx above 8,000. Okay, approx 8,500 approx. Okay, so for the exact values, again what you can do, you can use this cross tab, and in this cross tab you have to just mention from job type to ed type, and now you can see that only the doctorate, the masters, and the professor of the schools are earning greater than 50,000. And then rest of the other categories, as you can see, from the highest, from the 10th, there is 92 percentage people which are earning less than or equal to 50,000. The people who has graduated till 11th, means who have studied till the 11th class, are 94%, which are working less than or equal to 50,000. Then for the 12th also, in the graduation also, the person are earning 96% person are there whose earning is from first to fourth. You can see in the bachelors, you can see the amount is less, means 42% persons are also there who are earning greater than 50,000, but the persons are more in less than or equal to 50,000 categories, that is 57% approx. Okay, now let's just look out the occupation versus the salary status graph. So for that, again what we can do, we have to just change this from ed type to occupation. So now we'll see the salary status of all the categories based on the occupation of the persons. Okay, so if you want the exact figures also, so for that again you can use this cross tab method. Okay, and in this from ed type to occupation you have to just change it. So now you can see the exact values. Okay, so based on the uh, occupation, you can say that exercise managerial are the only highest. Okay, as you can see, which has 48% persons are in this category are earning greater than 50,000, and the 51,000 persons are earning less than or equal to 50,000 in this also. Now let's just at last we'll just look out the hours per week, okay, versus the salary status. So let's just look out that plot. So Now, for this, we have to create a box plot, okay? So we cannot create a count plot for that. So for that, we will have to create a box plot. So data2 and cell stat and y equals data 2, and in this we'll mention the hours per week, and then let's give out this data also using the group by method. For finding the median, okay? Now, if we'll first look at the median values, so you can say that the median value for greater than 50,000 is 40, and for less than or equal to 50,000 also, for that also is 40 only. Okay. Now, if we look at the graph, so from the plot, it is clearly visible. Okay, we can look at that those who make more than 50,000, okay, means if you'll notice on this plot which has greater than 50,000, so those who are working, uh, who are making more than 50,000, so means 50,000 per year, so they are more likely to spend 40 to 50,000, 40 to 50 hours per week. As you can see here, they are working at least 40 to 50 hours per week in comparison to uh, the less than or equal to 50,000 categories. They are okay, they are working less. So now we can say from all the conclusion from this box plot that this variable also can contribute in classifying the individual salary status, okay, because there is an association between the salary status and the hours per week also. Means the salary status is also based on uh, uh, the hours per week, that how much hours a particular person is working per week. So based on that also the salaries can be defined. So this variable is also it is also very useful. So this was how we found the relationship. Then we visualized the data, that which variables are very important in defining the subsidies, okay, of our salary status. So this was the first part of our case study, okay. So we are going to see more topics, that how we can conclude the subsidy, how we can find the subsidies, that to which persons the subsidy should be given, okay, without with the prevention of the misuses of it, okay, following the objectives. So that's all for today. I hope you understood something from this video. You will use it in different data sets or in day to day in your life. So thanks for watching the video. We'll see you in the